This is Sung, and I'm the Principal and Director of Sky Academy. And in this episode, what I want to do is look at how to add and subtract fractions. Now, the reason why I want to focus on adding and subtracting fractions is that adding and subtracting fractions is done one way. Multiplication and division is done an entirely different way. So the two don't mix. You don't mix the way you add and subtract fractions with the way you multiply and divide fractions, okay? So I want to separate and make that distinction, okay? Let me start by giving you some theory into how, give you an approach as to how you might add or subtract fractions, all right? There's two ways that there's two situations that you might encounter when adding and subtracting fractions. The first way is the easy situation, or the easier situation. The easier situation is when your denominators are the same. And of course we know that the denominator is the number on the bottom, okay? So when the denominators are the same, you just add or subtract the numerators, all right? The numerators being the top numbers, okay? If the denominators are different, we must convert both fractions to a common denominator before adding and subtracting. And I'll do that after I do the first type of situation. But let's do the first type of situation first. So you might see a situation where you got 5/6 minus 2/6. When you've got 5/6 minus 2/6, what you've got to do first is recognize that the bottoms are the same. Are the bottoms the same? Or the denominators the same? Yes. They're the same. Tick. So what you do is you leave the bottom the same, but then you minus the top from the top. 5 minus 2 is 3, and the answer is 3/6. Alright? 3/6, of course, can be simplified, and we learn how to simplify. Simplified to 1 out of 2. And this will come in handy later. Remember, when simplifying, what we are looking for is to see if there is a number that's common, that goes into both the top and bottom, that's common to both, right? A common, what we call a divisor, okay? Look for a common divisor. The number that goes into both 3 and 6 is 3. So you divide both top and bottom by 3, and you get 1 out of 2. Yeah? Good. The next one, 1/7 plus 4/7, are the bottoms the same? Yes, the bottoms are 7 and 7. Tick. That means we can add the tops together, alright? What's 1 pineapple plus 4 pineapples? Well, 1 plus 4 is 5 pineapples, and you do the same thing here. What's 1/7 plus 4/7? Well, it would be 5, not pineapples this time, but 5/7, okay? So the bottom number just tells you what we're adding together. We're adding sevenths together. So at the end of it, we should have 5/7. All right. Does this simplify? No, it doesn't simplify. So we don't have to work. You don't have to work that out. Okay. And how do I know? I just know that there's no whole number that goes into both 5 and 7. All right. Question number 3. 5/9 plus 8/9. Is there a common denominator, or is the bottom number the same? Yes, it is. The bottom number is 9. 5/9 plus 8/9, right? How many ninths would we have altogether? We would have 13 ninths. Now, if you recall, 13 over 9 is what type of fraction starting with I? Yeah, it's an improper fraction, right? So because it's an improper fraction, what we can do is turn that into a mixed number. 9 goes into 13 once. It has a remainder of 4, so it's 1 4/9. Now, can 1 4/9 simplify? Is there a number that goes into both 4 and 9? No. So the answer is just 1 4/9. We just leave it like it is. Now, I've chosen for question 4 a little bit more difficult example, and this tests your knowledge of mixed numerals more than it does your knowledge of addition and subtracting fractions, but it does come into play. Now, let me just go through this one. 4 1/7 minus 2 5/7, right? Now, are the bottoms the same? Yes, the bottoms are both 7. Tick. 1 minus 5, can you do that? You can't take 5 away from 1, right? So what you have to do is take 1 whole from this 4. So if you take 1 whole from this 4, you're left with 3 wholes. And that 1 whole that you've taken from the 4, right, becomes 7 sevenths. So 1 whole becomes 7 sevenths, right? So 1 whole, 7 sevenths, plus that 1 seventh becomes 8 sevenths. So 4 and 1 7 becomes 3 and 8 sevenths, minus 2 and 5 sevenths. The bottoms are the same, so it'll just be sevenths. 3 minus 2 is 1. 8 minus 5 is 3. So you're left with 1 and 3 sevenths. The tricky bit is being able to take 1 whole away from the 4, turn that 1 whole into 7 sevenths, add the 1 seventh that you've got, and you get 8 sevenths, right? And you do that because you can't take 5 away from 1. Alright? So you go 3 and 8 sevenths minus 2 and 5 sevenths, that gives you 1 and 3 sevenths. Alright? Good. Now what I want to do is look at how you add fractions where the denominators are different. Okay? Now where the denominators are different, what you have to do is convert both fractions to a common denominator. Now, here's what I want to do, and I'll use a black pen for this. If we were to convert, this is just a refresher, and it's kind of similar to what we did here. If we have 1/3, and if we had 3/4, and we were to convert both to 12ths, how would we do that? What do we have to do to 3 to get 12? We would have to times by 4, right? This is just a refresher on an episode earlier, alright? We'd have to times that by 4. Now, if we times the bottom by 4, we would have to times the top by 4, right? So 1/3 becomes 1 times 4, 4/12. What would 3/4 become? Well, you'd have to times the bottom number by 3, and if in order to keep the fraction the same, you'd have to multiply the top by 3, alright? 4 times 3 is 12, 3 times 3 is 9, so all of a sudden 1/3 and 3/4 becomes 4/12 plus 9/12. 1/3 becomes 4/12, 3/4 becomes 9/12. Now, if we were to then add these two together, we could do that, right? We could now do that because the bottoms are the same. So 4/12 plus 9/12 would become 13/12, right? Now, how do you know what number to convert both fractions to? So if you had an example like this, say 3/5 plus 1/3, how would you know what number to convert the bottom to? Well, basically, you would have to do what's called finding lowest common denominator, okay? In other words, it's the lowest number that both 5 and 3 go into, right? There's a number of ways to do this. What you can do is choose the biggest number and go up in multiples of that biggest number, okay? So you got 5, 10, 15, etc. All right? Let's say 20, and you go 3. Does 3 go into 5? And the answer is no, 3 doesn't go into 5. Does 3 go into 10? No, 3 doesn't go into 10. Does 3 go into 15? Yes, 3 goes into 15. So 15 would be the lowest common multiple, in which case you would put everything over 15, and you would go, what would you have to do to 5 to get 15? You'd have to times by 3. So if you times the bottom by 3, you'd need to times the top by 3. So you times 3 here, and you times 3 there, and you get 9 over 15. What would you have to do to 3 to get 15? You'd have to times by 5. So 3 times 5, 1 times 5 gives you 5 over 15, and then your answer would be 14 over 15. Does that make sense? Yep. Another method that you may have come across in different circles is probably called the crisscross smiley method. Okay. All right. So basically, the crisscross smiley method goes like this. So you go criss, cross, smiley. So what you do is you go 3 times 3 is your crisscross. Well, your criss is 3 times 3, which is 9. 5 times 1, which is 5. Because you're dealing with an addition, you put a plus sign there. 5 times 3 is 15. Alright, so you got the criss, you got the cross, and you got the smiley. Alright, and then you end up with an answer, 14 over 15. You come to the same answer there, right? So you got this method where you choose the highest number, write down the multiples of it, and see which of those multiples, which is the smallest multiple that the other number goes into, right? And then you convert both fractions, or you can use the crisscross smiley method. Where the crisscross smiley method breaks down is basically where you've got a fraction like this, 4/9 plus 1/3, right? And when you've got 4/9 plus 1/3, the reason why crisscross smiley method breaks down is this. If you look at 3 and 9, what you find is that 3 is a factor of 9. It goes into 9. And so your lowest common multiple, or your lowest common denominator, is in fact 9. So 9 goes into, so 3 goes into 9. 9 is common to both, right? Because 9, if you were to do the multiples, 9, 18, 27, you would stop at 9, alright? Because 3 goes into 9. So you wouldn't have to go any further. So you're actually guaranteed of having the lowest common denominator when you use this method, alright? So what you get is 4/9 and 1/3. You multiply 3 by 3 and 1 by 3 to get 3/9, and your answer is 7/9, right? And so see how your number is has got the lowest common denominator already factored into it? Yeah. If you were to use the crisscross smiley in this example, what you would find is that things get a little bit more complicated. And I'll show you what I mean. It doesn't get complicated because things get harder, but you're just dealing with numbers that are bigger, alright? And sometimes the bigger the number, the more cumbersome it becomes to deal with those numbers, alright? So the crisscross smiley method would work like this. Criss, 4 times 3, which is 12. Cross, 9 times 1, which is 9. The plus sign goes in the middle, alright? Smiley, 9 times 23 is 27. And your answer would be 21 over 27. And do you see that automatically you're not down to the lowest common denominator? You would have to then simplify, right? So 3 goes into both 21 and 27, so you divide both by 3, and your answer is 7 over 9. Okay? So that is how you do fractions where the denominators are different. You must convert those fractions to the lowest common denominator. So in the next episode, what we're going to be doing is we're going to be doing multiplication and division with fractions. And I'll see you on the next episode. Thank you very much for watching.